Voronezh diesel locomotive repair plant is the oldest enterprise in our region, where the ongoing process of reviving diesel locomotives and bringing them back to a united system of railway equipment lasts 145 years. The history of the plant dates back to the 28th of July 1868. At that time, a railroad was being built in Voronezh Governorate, and there was a plan to construct workshops for repair steam locomotives and wagons on a terminal depot. In 1928, the workshops were renamed Voronezh Steam Locomotive Repair Plant, and in 1929 it was named after F.E. Dzerzhinsky. Voronezh Steam Locomotive Repair Plant became one of the first largest industrial enterprises in Voronezh. Its workers were overhauling the most high-powered steam locomotives of the country. The production was growing and developing fast. Diesel locomotives replaced steam locomotives, and plant workers, by their own efforts, reconstructed and transferred the enterprise to the repair of the most high-powered diesel locomotives of that time. TS3, Voronezh Steam Locomotive Repair Plant, became advanced due to new technologies. Just before the Great Patriotic War, there were more than 7,500 workers at the plant, and its annual output amounted to several hundred units. In wartime, many workers were joining the army, others were producing ammunition. In 1941, plant workers built an armored train, and its battle team consisted of plant employees. Besides, the famous Katyushas were produced at this plant. A new life of the plant started in 1960. Step by step, the plant was shifting to the repair of the modern diesel locomotives. In 1983, the overhaul of diesel freight locomotives 2TE116 was assimilated. Year by year, the production output was growing. Even the crisis 90s, the plant did not fall to decay. Since 1998, the overhaul of diesel passenger locomotives TEP70 has been conducted here. More than 18,000 such machines have passed through the plant shops and got a second life. In 2007, a test model of new 8,300 kW gas turbine locomotive was built in cooperation with the Research and Technological Institute and submitted on trial run at the plant. The locomotive was equipped with turbine NK361 running on liquefied natural gas, with AC/DC electric transmission and axle-wise adjustment of traction effort. This unique machine may become a prototype of a locomotive of the future. Currently, Voronezh Diesel Locomotive Repair Plant, which is one of the 10 branches of joint stock company Geldor-Remmash, and a powerful high-technology enterprise equipped with unique machines, has great production potential and is fast-growing. In 2011, the plant assimilated the repair of the modern series of diesel freight mainline and diesel passenger locomotives TEP70U and TEP70BS, equipped with microprocessor-based system. In 2012, the plant initiated 2TE116K diesel freight mainline locomotive repair. Moreover, the plant prolongs the lifetime of 2TE116 and TEP70 series of diesel locomotives, conducts repair of electric machinery, wheel pairs and other units of diesel locomotives, meets requirements of the railroad and industrial transport in spare parts. Ensuring and enhancing the quality of products has always been the priority for the enterprise. The main customer of the plant is joint stock company Russian Railways. Besides, VTRZ also works with private clients. The diesel locomotives assembling shop was built in 1945. Today it is equipped with all the necessary manufacturing machinery for conducting intermediate maintenance and overhaul of 2TE116, TEP70, TEM2 series of diesel locomotives. Complete disassembly of diesel locomotives and transfer of separate units such as diesel engine, electric machinery and locomotives bogie to other shops of the plant are carried out at the diesel locomotives assembling shop. The shop conducts repairs of frames, bodies, fuel tanks, water, oil and fuel pipelines and locomotive brakes. Repair operation of airboxes, cabs, roofs, diesel locomotive final assembly out of the repaired units transferred from other shops are also carried out at the diesel locomotives assembling shop. Servicing and preparation of diesel locomotives to rheostat and running testing. After the repair, wheel load is tested by skeletonizing along axles and wheels. The diesel shop was built in 1945. It is fully equipped with manufacturing machinery for overhauling diesel engines of 5D49 type. Unit-wise disassembly, repair and assembly of diesel electric engine with application of special devices and test benches are conducted at the diesel shop. After the repair, the assembled diesel-electric engine undergoes trial run and testing at one of 3 special benches of the control and test station of the shop. Diesel-electric engine testing program is agreed upon with joint stock company Russian Railways and comprises the full stimulation operation of the diesel-electric engine of the diesel locomotive. Diesel-electric engine environmental attribute checking is an integral part of its testing. A multiplier is applied for loosening and tightening nuts of cylinder sets clamping. It enables nut tightening with capacity up to 600 kg per square centimeter by means of integral gear. The multiplier has noiseless vibrationless operation. The available suspension provides for free travel of the multiplier in vertical plane, which facilitates the work of the operator. The repair and picking shop, formerly called non-standardized shop, started working on the 1st November 1992. A water jet cutting device, OMEX, was installed at the repair and picking shop in the conduct of the investment program of Voronezh Diesel Locomotive Repair Plant, joint stock Zheldor-Rem-Mash, 2012. It is a precision machine with programmed control for abrasive flow machining capable of cutting complex parts made of different materials. Today, the device produces more than 300 parts from metal and peronite. 1 year earlier, in the conduct of the same program, a dynamic balancing machine of VM300 model with a vibration measuring instrument Sapphire 2 for balancing turbocompressor rotors 6TK and TK41 was acquired and installed. Self-aligning roller supports with flat-faced support rollers are used in the design of balancing machines of VM series. Rotor journals placed on such support are not distorted during balancing, and the machine rolls particularly do not wear out. Modern computer measuring system allows for conducting part dynamic balancing without reference rotors. A new building of the wheel and bogie shop, 9,948.4 square kilometer in area, was commissioned in 2006. The modern building accommodated equipment for overhauling bogies and wheel pairs of diesel mainline locomotives 2TE116 and TEP70. Among the main manufacturing operations of the wheel and bogie shop are repair and assembling of wheel pairs and bogies, bogie and wheel pair cleansing, status control of different units before and after the repair, repair and recovery operations, and final assembly are conducted at different areas of the shop. The area for axle boxes mounting on wheel pairs is equipped with production line enabling transfer of wheel pair during installation of axle box units. Laser system of geometric control is applied at the shop to ensure the accuracy of the bogie frame overall and mounting dimension. Based on the received data, a certificate is made for every tested frame. The hardware shop was commissioned in 2005-2006. Its production areas are situated on the 4 floors of the building and are fitted with the modern equipment in accordance with the technical regulation of joint stock company Russian Railways. Ultrasonic washing of parts was applied at the enterprise for the first time. Alongside with the washing quality, the physical form of the repaired parts has also improved. In connection with the introduction of microprocessor-controlled equipment on diesel locomotives, the plant purchased a set of control and checkout equipment. This bench considerably facilitated the process of assessing efficiency of USTA and USTA-AM systems, as well as the individual modules of these systems. In 2010, in line with the investment program, control and checkout complexes for modern complex locomotive safety devices diagnostics and computer-controlled track and speed detectors testing were purchased and installed at the hardware shop. In 2011, through investments, a smart complex called the System for Testing Diesel Engines and Diesel Generators of Diesel Locomotives of 2TE116 and TEP70 type was acquired. It enables to eliminate the human factor in the registration of results of locomotive testing and get the most objective data on the work of various systems of the diesel locomotive. The hardware shop has all the necessary benches for testing the brake equipment work, benches for crane operator testing, secondary driver's controller testing, benches for locking testing, and the block of electro-pneumatic valve testing. For production of cables, according to the universal technologies, the plant acquired equipment for application of marking using heat shrink tube and thermal transfer printing, as well as the equipment for cream pressing. Owing to the sophisticated organization of the area for locomotive speedometers repair and availability of modern testing equipment, the plant was licensed to carry out calibration locomotive speedometry. The electric machinery repair shop is fitted with technological equipment for intermediate maintenance and overhauling of tractional generators and power units of traction and auxiliary electric machines of diesel locomotives 2TE10, 2TE116, TEP70, TEP70U and TEP70BS. All operations are carried out at 5 main areas of production: traction generators, disassembly assembly area, anchor and reel sectional area, and the area for repair, auxiliary electrical equipment and auxiliary station. The repair is carried out with the application of equipment, special tools and test benches. Control over the quality of work is maintained step by step by the workers themselves, supervisors and QCD inspectors, with subsequent delivery of finished products to the inspection of the Technical Audit Center. In 2012, the balancer shank, which is designed for balancing a wide range of electric machines' rotors, was commissioned at the electric machinery repair shop. It made possible to optimize the balancing process by means of constant calibration and coherent sequence of operation. There are 3 manufacturing areas at the shop: hammer area, press area and spring area. The hammer area is equipped with forging hammers of 5 ton force, 3.15 ton force, 1 ton force capacities, and 2 die hammers of 3.15 ton force and 1.6 ton force capacities. The press area is equipped with 10 presses designed for hot and cold forging, bending, drawing spare parts of locomotives and manufacturing parts by forging. Manufacturing of springs by cold and hot winding and clamps out of sheet steel are carried out at the spring area. Automatic submerged welding is applied at the plant to ensure the quality of continuous welding of air tanks girth steam. This type of welding has several advantages over manual arc welding. High-quality welding is achieved by reliable metal protection, stable size and shape of the steam section, and 0 breaks in the welding process. High process performance, 10-20 times higher than manual welding. Material saving is achieved by reducing the loss of metal on scattering, 1–2% instead of 10% by manual welding, due to the lack of electrode stubs. Better working conditions. The arc is closed so that there is no radiation and considerably less gassing. The advanced technology of gas plasma cutting is applied at the plant. A GET PLC device provides fast and efficient cutting of any conductive metal. In comparison with gas oxygen process, plasma cutting is much simpler. Gas plasma metal cutting produces high-quality sheet metal blanks. In addition, defect sampling, surface gouging, welding chamfering, drilling holes in the blanks, art cutting are carried out by this method. The maximum efficiency of the plasma cutting is achieved through process versatility, high performance and accurate cut of any alloys and metals. The tool area provides the enterprise with an essential tooling in accordance with the technical documentation and production plans, thus ensuring efficient production and high-quality products output at the plant as a whole. A horizontal machining center GDN 500 with numeric control is designed for complex processing of basic parts in the accurate coordinates, contour milling with linear and circular interpolation and tapping. An automated induction heating device for high-frequency surface hardening of wheel pairs crown teeth enables enhancing the quality and increasing the volume of output. The automated hardening complex renders possible to move the inductor along the full vertical extent of a workpiece, rotate a workpiece at different speeds, adjust the inductor output current, both in manual and automatic mode, which reduces the influence of the human factor on the final result. In the process of repair, there is a constant need to check the physical condition of parts and locomotive units. There are work sites for non-destructive testing at all the shops. In order to improve the system of non-destructive testing, in 2002, a non-destructive testing laboratory was created in Voronezh, TRZ. The laboratory is accredited by the Accreditation Authority for Non-Destructive Laboratories on Federal Railroad Transport. Product quality control is carried out by means of acoustic, eddy current, magnetic, optical, radiation and capillary types of non-destructive testing. Non-destructive testing inspectors are certified with the 2nd and the 3rd qualification levels for all applicable types of non-destructive testing. Intensively developing production of the modern equipment for non-destructive testing enables the use of devices and installations that increase reliability and accuracy of control. Thus, the introduction of an installation Unimag 440AS for fluorescent magnetic control of bearing rings enable identification of multi-directional defects in the rings of box bearings, which gave an undeniable result. Since 2008, there has not been a single failure of diesel locomotives due to the destruction of box rings. In 2008, MKPR1 installation was introduced to control box springs and iron body springs, which directly influence traffic safety. Spring magnetization by monitoring is omnidirectional, which enables to detect both longitudinal and transfer defects. Optical control of parts with the use of video endoscope VD48 with flexible guided probe has been widely used since the beginning of 2012. It enabled to get rid of faulty fuel systems of diesel locomotives, which were caused by ingress of technical and other impurities in the fuel tank's elements, nozzles and diesel engine valves. Continuous improvement of the production technology, methods of output products quality control, as well as permanent systematic work on personal training, promoting the improvement of practical skills are necessary to enhance reliability and increase the operation life of the repaired equipment. Mentoring and supervision systems are applied at the plant. Experts and workers with extensive experience share their knowledge and assist in the adjustment of new employees. Currently, the enterprise employs about 2,000 people, and all kinds of social assistance are available for them. The union committee protects interests of the personnel. Plant workers receive high-quality health care. The enterprise helps prospective employees to obtain higher education. Among the things at the workers' disposals are a library, including a technical one, a spacious dining room, where the meals are always prepared with love, like for a family even so big. The gym is a particular highlight of the plant. People can not only work out for themselves there, but also prepare for the competition and display for the honor of the company. Nowadays, technological progress is advancing rapidly. Technological innovations strike our imagination, and railroad transport, which once seemed a miracle, has become quite a common thing for us. But like many years ago, today still mainlies secure economic and social development of the country. And like many years ago, we stand in awe of this technological wonder.